What is up, Five Keys? Good morning, Mr. Mike here. It is January 27th, 2022, morning time. For me, I don't know what it is for you. I'm having a bad hair day. Forgive me. My dog stole my hat. I can't even wear a hat. So carry on. That's all we can do, right? If that's the worst of my problems, it's a pretty good life. So today we are doing module 2, lesson 4B, which is more of the same, except there's a variation. And we'll see that in a second. So let's pull this up. The title of the lesson is Solving Equation with Variables on Both Sides. What is that? Well, it's exactly what it sounds. It's we're going to have multi-step equations or equations that require multi-step to solve for the unknown. And we've been seeing things like 2x plus 4 equals 8, let's say. To show you on a whiteboard. So we've been seeing this, right? 2x plus 4 equals 8. And we won't do the steps here, but maybe you can see that the answer to this problem is going to be 3. 3 times 2 is 6 plus. The answer to this problem is not going to be 3, my friends. The answer to this problem is going to be 2. 2 times 2 is 4 plus 4 is 8. But what were to happen if I were to say 8x? Oh my goodness. Well, now it gets more complicated, right? Kind of. It's actually not that much more complicated. But we will let the text guide us through, okay? So let me stop share. Let's do a new share and we'll actually share and look at the assignment. The first assignment for this lesson, module, whatever, together. Okay, so here we are. Unit 2, lesson 4B, solving equations with variables on both sides, a bunch of standards that we don't need to know really. Learning targets in this lesson, you will solve multi-step equations with variables on both sides of the equal sign, identify equations with infinite solutions. Oh, that is kind of new, I guess, or with no solutions. So yeah, there's going to be a lot of dealing with what we've already know, what we've already looked at. And for some reason, they're asking us this question here. And in order of operations, what is the first thing you look at? Well, you know, order of operations. Sometimes people use the mnemonic device PEMDAS, P-E-M-D-A-S. And the beginning of PEMDAS tells us is a P, which stands for parentheses. So that is the first thing that we look like. In this class, we've been talking about the mnemonic device GEMS, which is a little bit different and doesn't have a P. It has a G it begins with, which stands for group, which is the same thing as a parentheses. We choose that because it also covers brackets and it covers any operation that's happening in the top or the bottom, the numerator or the denominator of a fraction. Okay, so here's an example that they give us. Let's see what they say. Move this over. I just learned something, but you can't see it. That's okay. So 5x plus 2 equals 2x plus 14. What do we do with that? So this is a number times 5, that's 5x, plus 2 equals that same number times 2 plus 14. So how are they going to solve it? Well, they're going to use the subtraction property of equality, and they're going to subtract 2x from the right side of the equation. 2x from the right side of the equation. And they're going to do the same thing to the left side because that's what the subtraction property of equality tells us. As do most of these equality properties, whatever you do to one side, you have to do to the other side. And by doing that, it'll maintain the equality. It'll keep the equation equal. Okay, so the next step, this 2x minus 2x went to 0. So it's gone from the right side, 14. 5x minus 2x went to 3x, and we're still left with our plus 2 and our 14. At this point, it becomes a two-step equation like we've worked on in the past. So that should be at least in part familiar. Okay, so what do I want to say about that? Remember, this step here, in addition to being the subtraction property of equality, they're using what we call combining like terms. We talked about that in our last lesson to get from this step to this step. This reads, if this were a grocery list and X were the number of carrots I'm buying, 5 carrots minus 2 carrots plus $2, right? I can't combine carrots and dollars because I don't know how much carrots are worth. So I'm just going to do what I can do, which is say, well, if I had 5 carrots and I took 2 away, I'm left with 3 carrots now and $2. Over here, I had 2 carrots and I took 2 carrots away. I'm left with 0 carrots, but I still have $14 on the right. All right, so here's a you try. So I'm kind of learning this process as I go, but what I might recommend doing is pausing it and trying it yourself. Go. And then now you're back, and I'm going to show you how I were to approach this problem. So I'm going to rewrite it here. My mouse is being really grumpy today. Let me see if I use a different pad. If that will help. Yeah, it does a little bit. Okay, 7k plus 2 equals 4k minus 10. And I just want to show you something. I want to show you a different way of doing it. I'm going to give you 2 different ways. They're going to be very similar, but I just want to show you that the rule is going to work out whichever choice you make. So I'm going to choose then. So the idea here is I want to see a variable only on one. I want to see the unknown only on one side of the equation, right? Because that's how I'm going to solve it. I'm going to have k equals some number. So I'm going to have to get either my 7k to be 0 or my 4k to be 0. For this step, I'm going to choose to make my 4k 0, and I'm going to tell you why. I'm going to do that because if I were to subtract 7k for both sides, I would end up with a negative k. It's not wrong. It's not wrong, but it does make the math a little bit more complicated. I think it adds 1 step. But that's exactly what I'm going to do on the right side, just to show you that it's not, it'll give you the exact same answer. It just might be a couple more steps, or 1 more step, I should say, if even. Okay, so these are the additions I made, or the subtractions I made, I guess I should say. I'm subtracting a negative 4k from both sides. And I'm doing that so that this here, the 4k becomes a 0. And this is what I'm going to end up with. So if I have 7, I don't know what begins with a K from a grocery store, 7, not cookies, doesn't matter. 7Ks minus 4Ks, that's going to leave me with 3K. I haven't touched my 2, so my 2 is still going to be there. 4K minus 4K, that's 0, so I don't have to go near it. Oops, sorry. And then I'm left with a negative 10. If that's confusing to you as to why the 10 is negative, use the BOP rule, okay? The BOP rule is realizing that to subtract the number is to add the opposite of the number, okay? So this is a negative 10. what do I do now? Well, I'm going to subtract 2 from both sides. At this point, it's just a 2-step equation. I'm not saying just to diminish it, because that can be very confusing. I'm going to add the opposite instead of subtracting the positive, because sometimes that makes more sense to people. So the 2 plus the -2 becomes 0. Now I'm left with 3k. I'm choosing to work with the 2 because at this point I'm trying to get the k all by itself. And we've done this. So a -10 plus a -2, is it a party or is it a war? It's a party because the signs are the same. So I'm going to add. Is it negative or is it positive? Well, in the case of a party, when the signs are the same, the sign on the numbers is the sign on the sum. Notice I said the word sum. I said the word sum because the rules are different with multiplication and division. This is addition, so the sign 2 negatives is going to give you a negative. In the case of multiplication, that's not the case. Two negatives is going to give you a positive. I'm going to divide both sides by 3. This is the same thing as multiplying by the reciprocal. I'm essentially multiplying by 1/3 here. 3 times 1/3, or 3 divided by 3, same idea, is 1. So I have 1k. I don't need to write in the 1 because in algebra, we assume that there's a 1 next to a unknown if there's no other number there. Okay, -12 times 1/3, -12 divided by 3, same thing, is 4. Is it negative or positive? Well, I have 1 negative and I have 1 positive. A negative divided by a positive is a negative. Wow, that was a lot. Okay, so I have k is equal to -4. One last step. 7 times 4 is -28. Plus 2, this is going to give me -26. On the right side here, 4 times -4 is -16, plus -10 is -26. So that is a true statement. K is indeed equal to the opposite of 4, or -4. Okay, so just so I can show you, I'm going to do this vertically because oftentimes you'll see things modeled this way. If I subtract 7k from both sides here, I have this becomes a 0 because of the subtraction property of equality. I'm left with 2 on the left-hand side. If 4 minus 7, if I think of this as plus a negative, is going to be -3k minus 10. We can think of u as adding the opposite. So I have a -10 over here. I'm going to add the opposite of that number. And add the opposite of that number. Oops, I'm sorry. I forgot the k here. I'm going to add the opposite of that number. 12 is equal to -3k. Okay, now I'm not dividing by a +3, I'm dividing by a -3. And I ended up with -4 is equal to k. Lo and behold, it is the exact same answer as the other one because we just followed the rules, right? It's a chess game. You can make different moves. It's totally up to you what moves you make, as long as you're moving the pieces the way that they're the game tells you that you're allowed to move them. Okay, and then we're going to look at one last way to solve this problem, which is I don't want to call it this is a perfectly valid way of doing it. Mathway.com. I literally just copied and pasted. K is equal to -4. I do want you, I think there's a value to knowing how to doing this yourself and seeing how these things move. But at the very least, you can check your answer with Mathway, and also be familiar with that application, because there are lots of opportunities to use it in the future for things that are much more complicated, and it'll save you a lot of time. Okay, so all right, so lots of ways to do this. The trick to these problems is knowing how to address that there's a parentheses here, okay? So while I write this down, I'm only going to do this one way because there's a few more steps here. Know that these like number sentences don't really mean anything. Like there's no context to them. And sometimes the why, like why are we doing this, is a really tough question to answer. And the only thing I can offer you is that in the next lesson, we start to use what we're learning now to be able to create graphs and charts. And that does start to become relevant. And it becomes a different way of thinking about numbers. Generally, we're not thinking about simple addition and subtraction or grocery lists, but we really start to think of how we can model our world using some of the techniques that we're using. Okay, so the distribution property tells us that this 4, we're going to have to multiply it into each of the terms inside the parentheses. I can't combine my 2y and my -1 because they're not like terms, they're different. I'm trying I can't add 2 yams minus $1 because I don't know the cost of the yam. All right, so I'm just left with 2y minus 1. So to get rid of the parentheses, I'm going to have to distribute that 4 to both sides. So 4 times 2 times y, I can call this 8y. And you say, but wait, didn't you just combine terms that are different? I did over multiplication, which you're allowed to, because if you think about this in terms of like English words and the metaphor that we're using of grocery shopping, this is like the yams are coming in a pack of 2, and I bought 4 packs. So I bought 4 packs of 2 yams each. I ended up with 8 yams. Okay, I hope that helps. So 4 times 1, and the operator goes with us, is 4. If you want to think of this as adding the opposite, you can, plus a -4. Sometimes that makes the multiplication a little bit more clear. Same thing here. If there's ever not a coefficient, that's the number next to the variable. If there's ever no number written there, we assume it to be 1. So this is 2 times 1. We have 2 yams over here. And same idea here, 2 times 13 is 26. And the operator goes down with us, or we can think of it as plus and negative. Okay, so we can move either or. I can either move my 8. I can either turn my 8 into a 0, or I can change my 2 into a 0. I'm going to choose to turn my 2 into a 0 so that I don't end up with a negative variable. But in this case, because I can see a few steps ahead, it doesn't actually matter. I'll show you why. I won't actually show you why. It doesn't actually matter. I'll point out to you why when we get there. So I'm going to add a -2y to both sides. I'm adding the opposite. So there's my -2y over here. Okay, so then what do I end up with? Well, I have a -2y plus an 8y. Is that a party or a war? Well, it's a war because the signs are different. So what do? I subtract the smaller from the bigger, absolute value wise. 8 minus 2 is 6. The sign on the number with the higher absolute value distance from 0 is the sign on the answer. In this case, it's 8, which is positive. So this is a positive 6y. I'm left with 6 yams on the left side of the equation. I haven't touched my 4. My negative 2y plus positive 2y is 0. That's by design. 6. And now I have a two-step equation. When we've done these before, I'm going to do this vertically to save a little bit of space and time. Okay. I'm going to add the opposite of 4. The opposite of this negative 4 to both sides, which is positive 4. This goes to 0. That's by design. So I'm going to bring down this 6y. This has gone away. Okay, now I have a negative 26 plus a positive 4. Is that a party or a war? It's a war because the signs are different. So 26 is it has the bigger absolute value. So if I take 4 away from 26, I'm left with 22. Is it a positive or a negative? Well, it's a negative because the number with the bigger absolute value is negative. That's 26. And now I'm going to divide by 6. I'm going to divide by 6. That's the same as multiplying by the reciprocal of 1/6. And I'm left with y is equal to negative 22 over 6. I can simplify that into negative 11 over 3. If we had gone the other way around, where we subtracted 8y from both sides, this number without the variable on the left would have been positive, and we would have been dividing by a negative coefficient on the unknown, and we would have still got a negative number. In fact, we would have still got 11/3. Okay, so again, if this is a good moment to pause it, try number B on your own, letter B on your own, and when you're done, come back. Okay, so I'm going to abbreviate a little bit of this work. I'm not going to write out the problem again. I'm just going to do the distribution. I'm distributing here. So 7 times 4, that's my first one. That gives me 28. Whoops, let's change my color. 7 times 4 gives me 28. Well, now this is interesting. Minus a. Well, I know that there's a coefficient of a 1 in front of that a. So I have 7 1a's that we're subtracting, which becomes 7a. Okay, now moving on to this. 3 times a is 3a as a positive. Minus 3 times 4, which is 12. Okay, again, I'm going to just hop in and work vertically here. So the last time we ended, so let's look at what happens when we have a negative variable, okay? So I'm going to subtract 3a from both sides. Subtract 3a from both sides. I have 28. Well, now this is interesting because I'm subtracting a positive 7a. So what is that? Well, what is, if I'm subtracting a positive 7a and then have this negative 3a, here's where subtraction does get genuinely confusing when you're doing algebra. And you will get to a point where you can see it very clearly, and when other people get confused, you won't even understand why. I promise you, you'll get there. But I can understand why this would be really confusing if you're still wrestling with adding and subtracting negative integers. My recommendation here is to change this to, I'm going to add the opposite so that you can very clearly see that this is more negative than anything. This is a negative 7a, and I can even do that here too, plus a negative 3a. Okay, so I have a debt of 7 apples and a debt of 3 apples. and this becomes a negative 10a. Okay, positive 3a minus 3a. That one's pretty straightforward. That goes to 0. We did that by design. And now we have a two-step equation. Okay, so what do? Well, we subtract 28 from both sides. It might help also to think of this as plus a negative 12, so you understand that negative goes down with it. Subtract 28 from both sides. Again, I'm going to add a negative so that it makes a little bit more sense to us. This goes to 0. That was by design. Sorry, I kind of got sidetracked by something. Okay, so what's a negative 12 plus a negative 28? Well, it's negative 40. My last step, I'm going to multiply by 1/10 or divide by 10 so that the coefficient on the unknown becomes 1. And I'm left with A is equal to 40 divided by 10, which is 4. Is it negative or positive? Well, two negatives when you're dividing and multiplying become a positive. So in fact, it is positive. Let's check our work really quick. This one I feel like I might have made a mistake on because I feel like 11/3 is a really weird number for it to turn out to. But let's see, maybe I didn't. So we had 11/3 and we had positive 4. Don't forget because I have to erase the drawing. Okay, boom, boom. Solve for y. Negative 11/3. Sweet. And then let's do this. And we said that this one was positive 4, right? Let's see what we got. A is equal to 4. Great. And that makes that I should have seen that a little bit more clearly because if I plug in 4 here, I get 0, right? And 0 times any number is 0. If I plug in 4 here, I get 0. 0 times any number is 0. Sweet. Okay. That one was a little bit more clear. Okay, so they're giving us this idea of there are certain problems that are going to have no solutions, and there are certain problems that are going to have an infinite number of solutions. The answer is below. So why does 5x answer below? Sorry, why does 5x and 5x have infinitely many solutions? Well, x is always going to be the same number. We just don't know what that number is. So it's not like x is going to be different on the left or x is going to be different on the right. So you can put any number there and it's whatever number it is times 5 because the multiplication property of equality is going to be the same. And what we call that is infinite. There are infinite many solutions, or x can be all real numbers. In fact, I think x can be all numbers. I don't think there's a case of an imaginary number where you would get two different answers. So what's going on here visually? And this will make more sense as we get into later modules. I just want to prime it for a second. Is 5x can represent a line. If it's y is equal to 5x, you would end up with a line, and it would look something like this: loop, loop. So if 5x equals 5x, well, I'm looking at the same line is overlaying each other, okay? And so all the numbers on that line, and again, this will make more sense later, I'm just kind of priming it, they're gonna overlap and they're all gonna be correct. Okay. All right, cool. So solve this. So here's a special case. They solve it, and look, they came up with exactly the same thing on both sides, 14x plus 12. So you can plug in anything for x, and you'll get the exact same answer because they're identical. But they weren't identical initially, right? They looked different. we had to do a little bit of math to show that, oh no, this is the exact same line. This is the exact same expression on either side of the equation. Okay, so here's another example where they are doing some math here. They have this equation, 9m minus 4 equals 3m plus 5 plus 12m. And as they're working, they end up with 9m on both sides of the equal sign. They subtracted out, and what? They got negative 4 equals 5, which is not true, right? There's no solutions here. You just ended up with a incorrect equation. What's going on here is that this represents a line and this represents a line. And again, I'm just kind of priming it, but I want to give you something visual to kind of hold on to. It's because it'll make much more sense. And generally, if there are solutions, like in the case of 2m plus 6 is equal to m minus 2, let's say. There's a solution to that problem. I don't know what it is. We don't have to do it just yet. 2m is a line. It looks kind of something like this. 2m plus 6, sorry. M minus 2 is a line. It looks something like this. And this is the answer for what m is. Whatever that point is there, or the this distance. That's what m is. Again, we'll get there. This will all make sense later. I'm just giving you a little bit of visual context. So think about, this is a line, this is a line, the lines intersect, the point at which they intersect is our answer. So in the case of no solutions, what it looks like visually is this, is that I have my axis here, sort of the worst axis ever, maybe not the worst ever, but it's not good. And I have, I have one line. This is, let's say 9m. This is 9m plus 5. And then I have another line, which is 9m minus 4. And it looks like this. And these two lines are what we call parallel. It's kind of like a freeway. If you're driving on the freeway and one traffic is going left and one traffic is going right, one traffic is going north, one's going south, let's say, those two things are always parallel to each other. They may be like spinning all around and stuff, but they're always going to be left and right. They're not going to intersect, right? If they do, we're going to have a problem, right? Because cars are going to crash. So parallel lines never intersect. As such, they don't have a solution. The m's are just going to go away. And then the numbers aren't going to be valid either. Okay, so infinite numbers, a problem with the solution, the lines are going to intersect. The problem with an infinite number solution, you're on the same line, they just overlap. No solution, the lines are parallel. Those aren't parallel lines, but I think you get my point. That's bloop. Okay. So you try, pause it, and come back when you have an answer. And then I will do it for you. Okay, so let's see what you did. The idea here is probably that these are going to be no solutions or infinite number of solutions, right? Let's see. So I'm going to take this, I'm going to distribute the left side. So 3 times 4b is 12b. I'm going to change my -2 into plus a negative. So I'm going to have a plus a -6 on my right. what is going on? Okay, look at this. So just to point it out, you can swap addition and it's okay, right? So a plus b is the same as b plus a, and that's exactly what's going on here. Here's a -6, here's a -6. Here's a positive 12b, here's a positive 12b, even though I forgot to write the b in. This is the exact same thing. We're going to end up with -6 equals -6. So what is that? But let me do the math really quick. Okay, so my first move in the chess game would be to get the 12, to get the b's all on one side. So I'm going to subtract 12b from both sides because I have a positive b here. This b happens to go to 0b, so I don't even need to write it. So plus a -6. Then I'm left with -6 plus, oh look, that's also 0. Okay, so I have -6 equals -6. Is that a true statement? Yes. Does that tell me what b is? Well, b went away, right? But I can put anything in there for b, literally anything, and still get a true statement because it's the same line. So what's the answer here? The answer is infinite solutions. And infinite is a word that means keeps going forever and ever and ever. Like, so if someone were to say the universe is infinite, it means the universe keeps going and going and going. It never actually stops. So yeah, that's what the word infinite means. So there are infinite number of solutions to this equation right here. All right, let's take a look at B. So I'm going to distribute here, bop and bop. So I end up with 2x plus 7 equals, what's -1 times +3? It's -3. What is -1 times +2? Well, it's negative, but this, we can think of this as plus a negative. So I'm going to call this plus 2x. Now I want my variable to be on one side of the equation, but I already see that my variables are going to cancel out. So I have a positive 2x over here, so I'm going to subtract 2x so that it goes to 0. But whatever I do to the right, I have to do to the left and vice versa. 2x positive minus 2x, that goes to 0. That was not by design. So 7 equals, I'm going to bring down my -3. Positive 2x minus 2x is 0 also. That was by design. So now I have this statement, 7 is equal to -3. I'm going to draw a line through this equal sign so that the statement is true. 7 does not equal -3. They're at completely different places on the number line. So what is that? Well, that means that if we were to graph these two things, and I know we're not there yet, but we would have lines that were parallel to each other. Another way of thinking about that is they have the same slope, they have the same steepness, but they're at different places. So this is no solution. There is no value for x for which this is true. Okay. Oh, lo and behold, we are done with the worksheet. So let's take a look at the quiz, and then that'll be it for module 4 lesson. Oh, that's not true. Module 2 lesson 4b. Just want to move this to my trash because I keep forgetting, and I have all of these copies in my drive. Okay. So now's a good time to pause it and to do the quiz on your own. You don't have to submit it. You could wait to submit it until you change the answers if you like, or you can submit it and let me see your work so that I could give you really accurate feedback on what you're doing right and what you're doing wrong. Where are we? Module 2. I'm sorry, guys and gals. And all those in between. Here we go, quiz work. So the other option, I guess, is to, you would submit your quiz here. This is the online, and you can submit the work that you're doing on the quiz work. You don't have to, but if you want feedback on what's going on with your math, you're welcome to. So what is the solution of 10m plus 8 equals 7m plus 17? All right. Well, we learned in the worksheet that the first thing we want to do is to get the variable on one side of the equation. So how do we want to do this? Well, I'm going to recommend, and you can do it the either way, that we start off by moving the 7m. So let's make this 7m side 0 and see how it affects the left side. So I'm going to add the opposite of what's on the right, which is the -7. So I'm going to add the opposite. Okay, so I have a -7 and a +10. I'm adding them together. So it's not necessarily a negative and a positive is a negative. It's addition. It's not multiplication, right? So is it a party or a war? Well, it's a war because the signs are different. So I'm going to take away the number with this smaller absolute value from the bigger one. That's 7. 10 minus 7 is 3. I do have an unknown with it. It's a positive or negative. Well, the number with the bigger absolute value is going to give the sign. That's the 10. The 10 is positive, so it's positive. I haven't done anything with the 8 yet, so I'm just going to write that there. -7 plus 7m, -7m plus 7m is 0. That's by design. That's why we did it. We wanted to go away. Equals 17. And now I have a two-step equation, and we've been working on this. So I'm going to subtract 8 from both sides, subtract 8 from both sides. 3m is equal to 9. You may be able to see the answer so far. I'm going to divide by 3 on both sides. This is the same as multiplying by the reciprocal of 1/3 on the coefficient. M is equal to 9 times 1/3, which is 3. Okay, m is equal to 3. We can put it back into the original and see 10 times 3 is 30 plus 8 is 38. Equals 7 times 3 is 21 plus 17 is 38. And you can do this very, very quickly. M is equal to 3. Great. All right. Okay, the solution for 3a plus 2, 3 times the quantity of 4a plus 2 is equal to 2 times the quantity of a minus 2 is a equals -1. Okay, this is not what the lesson's about, but I'm going to show you a different way of doing this. Because sometimes math is about doing different things, right? What were to happen if I were to just plug in a is -1 into this expression? I should get to, I should get the same number on both sides, right? So 4 times -1 is -4 plus 2. This is times 3. All I did was I substituted the -1 in for the a, and I went a times 4 times -1 is -4 equals 2 times a. I'm going to substitute in my -1 minus 2. Okay, this is 3 times, here's my integer addition, -4 plus 2 is -2 equals 2 times -1 minus 2 is -3. 3 times -2 is -6. 2 times -3 is also -6. So yes, this is true. If we had used any other number, we would have gotten a wrong answer. Let me show you what I mean. What if we had said a is equal to +1? Watch this thing prove me wrong. No, I think I'm good. I got nervous for a second, but I'll tell you why after I do it. So let's say 4 times a +1, which is the 4 plus 2 is equal to 2 times a +1 minus 2. This is 3 times 6 is equal to 2 times 1 minus -2 is -1. And I end up with 18 is very much not equal to -2. Okay, why did I take the time to do the other number? Well, I took the time to do the other number because I wasn't 100% sure that that this wasn't the same line, right? So what I mean by that is when we start to see things graphically, I thought I had this, where this was -1, but I could have had this, where there was the same darn line and it would have been infinite numbers of solutions. And this statement would have been false. This statement would have been false, but they didn't do that to me. So we are good. This is the answer to question number 2 is true. What does the equation 3x plus 7, forgive me, why does the equation 3x plus 7 equals -3x plus 2 have no solutions? And then the options they give us, because there are too many variables. Well, that doesn't quite make sense, because 7 is not equal to 2, only they misspelled equal, and because x equals either 7 or 2. Well, that's just weird. I don't know what that means. It's weird. I don't really get what that means either. So by process of elimination, I'm going with this one. But I still don't really get it, but let's see if I do a little bit of math. If it starts to make sense. So I'm going to combine like terms in the first move, okay? So I'm going to end up with 3x plus 7. And when I say combine like terms, I should have said I'm going to combine like terms on one side of the equal sign. So if I have -3 carats plus $2, and then I add 6 carats, I have a +3 carats, right? Plus 2. And now I know my next move would be to eliminate using the addition or subtraction property of equality one of the variables from one side, so they're all on the other. So I'm going to subtract 3x from both sides, but oh look, this is not by design. 3x minus 3x is 0. I'm left with a 7 here. 3x minus 3x by design is 0. I'm going to end up with 7 equals 2, but 7 does not equal 2. So this makes more sense now. Okay, that's it. That's all I got. That is lesson module 4, module 2, lesson 4B. And our next lesson will be on literal equations, which will be really exciting. Maybe that's an exaggeration, but it might be. I don't know. So, all right. Thank you for your work, and I will see you on our next module lesson. Bye.